All right. Hello and welcome to my presentation. My name is Kenji Kanagaki, and I will be presenting to you a hypothesis I've been contemplating on for about a month now. But first, a word of warning. It should be made clear that since this is a hypothesis by myself, a person who is not an expert in this field, the facts presented in my hypothesis are verified as true, but my analysis of those facts, aka my conclusions, are not. Therefore, they should be taken with a dose of skepticism or a grain of salt, as it were. Now, with that out of the way, let's get on with this presentation, shall we? Let me give a recap of global warming and climate change. We know that Earth is getting hotter and hotter as years go by. This is due to the greenhouse effect, or to be more specific, a runaway greenhouse effect. What the greenhouse effect is a result or effect of heat absorbent molecules called greenhouse gases trapping solar energy reflected off of Earth's surface, thus warming the planet's atmosphere and maintaining our habitable climate, like a greenhouse. Now, I mentioned a runaway greenhouse effect. This means that the greenhouse effect is out of control, and that is mainly due to recent human activity. Ever since the start of the Industrial Revolution, humanity has relied more and more on the combustion of fossil fuels and other polluting chemical processes to a point where products, carbon dioxide, CO2, nitrous oxide, N2O, and excess hydrocarbons, the molecules made of CH, are being emitted more than they are being expelled or absorbed by Earth's natural cycles. So they end up in the atmosphere, left to absorb much more heat than is optimal for most life on Earth. Hence, runaway greenhouse effect. But what does this have to do with jet stream blocking? Well, let's see in the next slide. In short, a jet stream is a fast current of air up in the atmosphere, which steadily moves weather systems across the surface. Around the mid-latitudes of the Northern Hemisphere, such as where the United States is located, jet streams move low-pressure systems from east to east, which bring cloudy, windy, and potentially wet weather. Jet stream blocking, as its name suggests, blocks these weather systems from progressing downstream. It is when a high pressure weather system stops or even deflects the low pressure system, bringing months to years of dry and stagnant weather. This prevents the upper tropospheric water vapor from reaching below its boiling/condensation point of 45.6 degrees Celsius at 0.1 atmospheres. As for the runaway greenhouse effect's role in this, it makes these blocking events more frequent due to the fact that the warmer water vapor from the south is meeting with the colder, freshly melted and evaporated Arctic water vapor, but not causing precipitation. Blocking stabilizes the polar jet stream, which causes it to oscillate and make their weather systems more violent when the opposite temperature water vapors meet, as seen in the meridional jet stream flow to the right. And with that information established, what does all this mean? Well, think about a stereotypical Black Friday rush. A particularly excited crowd of customers gathers at the door of a department store the day before it opens, Thanksgiving. The store then opens and the crowd stampedes in and purchases all the products available, leaving carnage in their wake. And before you know it, they're gone. This is what I think happened last month with the weather. As our emissions intensify the greenhouse effect, more water in the Southwest Pacific will be evaporated and brought all the way to California instead of precipitating earlier in the West Pacific, because the increased energy in the atmosphere keeps the water vapor from condensing. This means that the jet streams will bring more water vapor in the low pressure systems, which will concentrate near the high pressure block in California. When the high pressure system moves elsewhere, the compounded low pressure system, or bomb cyclone as it is called, rushes in and instantaneously introduces cold, windy weather with torrential rain and suddenly disappears. This results in flash floods, downed trees, power outages, carnage. This, I think, will keep happening as we emit more greenhouse gases into the atmosphere to the point where we will have superstorms and extreme droughts. In other words, human-driven climate change essentially allows more energy to circulate, which makes the Earth's climate have more intense and unpredictable weather, such as the heat wave and the bomb cyclone we had in October. And with that, that concludes my presentation. I hope you found that interesting. If you have any questions or comments, leave them in the Zoom chat and I'll do my best to answer them. Thank you for listening.